So hello everyone, in the last session we are seeing the circuit theory, so let us start with that. Yeah, so we have solved some example, so let us proceed our example. So this is example number 4 I guess. Okay. Now let us take one more example, example number 5. Okay, and I hope this will be your favorite example. I hope it will be your favorite example, but I have not able to draw it correctly. Let me draw this correctly. Okay, just for you. This is 10 volt, this is 6 volt, this is 2 ohm, this is 4 volt. Yeah, you have to find the current in all the branches. Okay, so this is a very important question. So how will you solve? What is the steps we have to follow? We have to take 0 at one point. Where point you will take 0? Take 0 here. Let's, this is 0, this will be also 0, this will be also 0, this will be also 0. If this is 0, this is a positive terminal, so this will become 6 volt, correct? Similarly, this is also a positive terminal, so this will add up, it will become 10 volt. Sorry, it will become 10, will become 10 volt. If this is 10 volt, this is also 10 volt, this is also 10 volt, correct? Now this is also connected to positive, so this is 10, this will be also 10, and 10 plus 4, that is 14 volt. So this is also 14 volt because there is no wire is there normal. So what is the current here? 40, sorry, what is the current here? 14 minus 0 divided by 2, that is how much? 7 ampere. In this branch we have 7 ampere current. Similarly, in this branch, if you see higher to lower potential, so 10, what is the current? 10 minus 6 divided by 2, that is 10 minus 6 is 4, 4 divided by 2, that is 2 ampere current from this branch, correct? 7 ampere current from this branch, if you will see, and 2 ampere current is going from this branch. So obviously, how much current will come from this branch? 9 ampere. Then only you will get 7 plus 7 here and 2 here. Okay, that is a common sense that we have seen in the basic thing. Okay, is it clear to you? Till here, anyone have a doubt? Anyone have a doubt? Okay, so that is the examples we have seen. Like to solve any circuit, what you have to do? Simply take a point and let us assume at 0, and then start. What you have to do then after that? Then you have to start taking, then I have to simply mark the potential at every point and solve it. Clear? That is a simple approach. That is a basic simple approach to solve any circuit. Okay, now we will return back to this. Before that, let us learn about the small concepts. Okay, so the first thing is called as a KVL. Okay, that is a very important powerful tool. Okay, that is called as a Kirchhoff's forgive me if I am writing the wrong spellings. Kirchhoff voltage law. Now what is Kirchhoff voltage law basically? Kirchhoff voltage law states that if you are moving in a closed loop, okay, if we are moving in closed loop, the summation of potential difference equal to 0, okay, based on energy of conservation. This is the statement. No one is going to ask you the statement. Just for your notes, I have written the statement, energy conservation. Clear? Important thing is that how will you apply the KVL? What is the approach to apply a KVL? Simple thing. See, KVL approach is very simple. We know current always flow from higher to higher, potential to lower potential. That is a simple approach. Current always flow from higher potential to lower potential. That is the thing we know. Okay. So what you have to do, suppose I have a okay. So if we are, suppose this is my resistor and the current is I, and suppose this potential is VA and this potential is VB, then how to apply the KVL? Let's see here. For resistor just I am telling, this point potential is VA. Then we know that the current is going from higher to lower, so write it as plus and minus. So we are current, what is the potential drop across the current? That is I into R. Potential drop across the current is I into R. Now the thing is that whether I have to take I into R plus or I into R minus, that is the thing. So see, the current is going from higher to lower, means the potential is decreasing. The current is going from higher to lower, the potential is decreasing. So what you will write? Minus IR. And this whole potential should be equal to the potential at B, because this whole drop is equal to potential at B. That is a simple thing. Or you can see from battery concept, higher potential minus lower potential is equal to how much? I into R. That is also you can get from here also, VA minus BB is equal to IR. So basically for a resistor, if there is a resistor, I want to apply the KVL, what is a simple approach? Always what you have to do, you have to mark the direction of the current. In the direction of the current you have to mark the potential. The current always flow from higher potential to lower potential, so you have to mark plus and minus. Then move in the, like basically you have to move in the, try to move across the resistor. So if you are moving along the direction of the current, simple, if you are moving along the direction of the current, the potential will decrease, because current always flow from higher to lower potential to lower potential. So if we are move along the direction of the current, the potential is going to decrease, so you have to take minus sign. For resistor, this is I am telling only for resistor, don't be confused, this is for resistor. Okay. But for battery, let us talk for the battery. For battery, what you have to simply do, suppose I am moving like this, or maybe second case what can be happen, I will move like this. So in this case, what you are, from where you are moving from, you are moving from positive terminal to negative terminal. So what is the sign you have to take? You have to take negative sign. And you are moving from negative to positives, and what you have to take? You have to take positive sign. Simple thing. Just note these 3 points. You can write the KVL in any circuit. Just let me tell you. I will take very simple example. Let us take very simple example. Okay. Suppose this is some part of the circuit. I don't know. Suppose this is 5. Let's take some part of the circuit. Example. Suppose this point is at potential VA. This is 5 ohm. Okay. Then we have a battery of 2 volt. Then we have a resistance of 3 ohm. Then we have a battery of again 3 volt, and this is potential VB. My question is that you have to find VA minus VB. So let us see how will you do this. And suppose the current in this branch is, obviously it is a series, so current will be same only, that is 2 ampere. How to write the KVL? Let's just see properly. First try to see and understand the things. First what you have to do, see current is going from higher potential to lower potential, just mark the terminal. This will be plus, this will be minus, because current will always flow from higher to lower potential. Just remember this thing. So this is plus minus. Similarly here also plus minus, because the current will be 2 ampere. Ampere only in series combination, current will be same. That is a basic thing you know in class 10. Okay. So now you have marked all the terminals potential, battery plus minus, minus plus. No issue. Now let us start. This potential, this point potential is VA. Then you are coming from this point, you have started. This potential is VA. Now you are passing the resistor. You are going from a resistor. So what you have to, what is the potential drop across the resistor? I into R. Now we are going from plus to minus, so minus I into R, correct? Now you come to the battery. Battery, you are going from higher to lower, plus to minus. So how much is the drop? Minus 2 volt. That is what I told you. If you go from higher to lower, minus. Clear? Now here plus to minus, again plus to minus we are going. So I will write minus 3 into 2, minus 3 into 2. Now again there is a battery, but it is minus to plus, means we are going from minus to plus. So we will take plus sign, plus how much? 3 volt. That is equal to this potential. Clear? That is equal to this potential. Now you calculate this. VA is equal to minus 10 minus 2 minus 6 plus 3 is equal to VB. So what is my VA minus VB? VA minus VB will be, that is how much? 12 minus 6, 12 and minus 3, to 12 minus 3 is plus 15, correct? 12, 12, 6, 18, 18, 3, 15 volt. So have you got the point how you have to write the KVL? Basically, simply what you have to do, you have to follow these 3 steps. See, for battery, how you decide the whether it is positive sign or negative sign? Simply what you have to do for a battery, for a battery you have to see whether you are going into the positive terminal or negative terminal. If suppose in current we are going in this manner, if we are going in this manner, then we are going from minus to plus, so we will take plus sign here. So it is depend upon the wind in which direction we are going, but the concept is always same. When it is higher, when we are going from higher to lower, always take plus sign. When you are going from lower to higher, always take minus sign. That is a simple concept you have to remember. When you are going from higher, what is overall you have to remember? Whenever you are going from higher to lower, take minus sign, and lower to higher, if you are going lower to higher, then take plus sign. Simple thing, simple approach, very simple. No need to think anything. Now directly apply the KVL. Wherever you want, you can apply the KVL. Let us take examples. Let us take examples so that it will be clear to you. Let us take one example. Okay. My question is, again you have to find VA minus VB. Okay, the circuit is this. This terminal is A. 2 ohm. This is 4 volt. 3 ohm. Plus minus 2 volt. 4 ohm. Point is B. Correct? And the current is, this branch is 2 ampere. Question is VA minus VB. Okay. Note it down and solve it. Till then I will write the another example. Note it down and solve it and tell me what is the answer for this. Okay. In this question, what you have to tell? You have to tell VA minus VC and VA minus VB and VB minus. Basically, this is your homework. Okay, this I am not going to solve for you. VB minus V. Okay, this is your homework. You have to find all the 3. Okay. And this branch I have not given the current. The current in this branch is 1 ampere and the current in this branch is 3 ampere. Clear? These things are given. Now you have to find the value. So obviously 3 ampere from here, 1 ampere is from here, so obviously 4 ampere in this branch. So now you have to calculate the things. Tell me the answer for this one. How will you do that? How will you solve it for this how will you solve? First, what is a step? Just write the, see, current is flowing from here to here, so plus minus. This is minus plus, this will be plus minus, because it will move, 2 ampere will go from here also, na? Plus minus, correct? Then minus plus, sorry, this is a resistor, plus minus, how much is the value? 2 ampere, correct? Now let us start writing the KVL. VA plus minus means minus 2 into 2, then minus plus, so plus, how much? 4 volt, then plus minus, minus 2 into 3 means higher to lower we are going, then again higher to lower we are going, so minus 2 volt, and again higher to lower we are going, so minus 2 into 4. That should be equal to VB. So what is VA minus VB? What is VA minus VB? That is equal to, see, 4 plus 4 minus 4 will cancel out, we will left with 6, and there is also 6, and 2 is 8, 8 and 8 means 16 volt. Clear? VA minus VB is 16 volt. Till here everyone is clear? Just note down this example for your homework. Have you note down? So I hope you understand about the KVL. What is KVL basically and how to write the KVL. So let us talk about another rule, or before the another rule, let us talk about something called, or let us discuss first another rule only, that is KCL. What is KCL? KCL is called as a Kirchhoff's current law. What is Kirchhoff's current law? Basically, Kirchhoff say that the total I net, okay, at any node, node means a point where we have a more than one terminals, more than two terminals are there, at any node is equal to 0, or you can say at any node, incoming current is equal to, outgoing current. Incoming current is equal to outgoing current. Is that clear? That is a basic. First you have to understand what is node. Node means simply I am telling just for your point of view, node means simply a point where we have more than two terminals. A point where we have more than two terminals. Okay, so let us take one example, then we will understand it better. Basically what I am trying to say, first understand about the KCL. Okay, let us suppose some node means more than two terminals. Suppose there is a one terminal is coming, it has a current I1, one terminal is there, it has a current I2, one terminal is there, it has a current I3, one terminal is there, it has a current I4. So what I am saying, the total incoming current is equal to outgoing current. So what are the incoming current toward the node? I1 is incoming, I4 is incoming, so I1 plus I4 is equal to, what is the outgoing currents? I2 and I3 are outgoing currents from the node, that is I2 plus I3. Simple thing, correct? Are you getting my point? So if you see, this is not a new rule. That is what thing we are applying here also. See, 6 ampere is coming, 12 ampere is coming, we are adding it and making it 18.5 ampere. That is the same thing. If you apply the KVL KCL also, you will get the same value. That is nothing. So we know the KCL basically. Just we have given a name here. Okay. So the simple thing you have to remember, the total current at the node, at any node, is always equal to 0. The sum of the total current at any node is always equal to 0. So let's do the sum of this. So what you will do, you will bring it here. So you will get, it is I1 plus I4 minus I2 plus I3 is equal to 0. Means if you are taking incoming current as positive, take outgoing current as negative, and if you are taking incoming current as negative, take outgoing current as positive. So there is a, if you don't want any confusion of positive and negative, just simply apply the one thing. Remember one thing, that is total incoming current is equal to total outgoing current. That is that is only sufficient for you. Whatever the total incoming current at the node, that is equal to the total outgoing current of the node. That is a simple approach you have to remember. Clear? Simple approach, and it is very important, but like very easy. KCL is very easy. We will see how to solve the questions on the KCL also. We will understand what is KCL basically, and we will try to understand the KCL. Okay, is it clear? Is it clear? Any doubt is there? So if I ask you very simple question, suppose just for your, like, have you understand or not? Just a simple question, let me ask you. Suppose there is some branch 2 ampere is coming, there is another branch 3 ampere is going. So what is the current in this branch? I. The arrow I have given. If it is not given, then you can make arrow in what direction, whatever you want. But it is given, then you have to consider that arrow only. Clear? So what you will write? Incoming current, that is 2. There is no other incoming current is there. So simply you will have just only one incoming current is there, 2. That is equal to outgoing. What is outgoing current? 3 plus this is I. So what is the I value you will get? That is minus 1. So what do you mean by this minus 1? This minus 1 sign indicate that the current exact direction is not this, it is like this. Means the current is not going in this direction. Whatever the direction is given here, the correct direction is this. Means here the current is 1 ampere. Means we have taken this direction is positive now. So we get a negative value. That means the current is actually it is in this direction, and that is obvious also, because 2 ampere is coming from here, then 1 ampere will come here, then only it will make 3 ampere. Obviously, are you getting my point? So that means this minus sign indicate that the direction is opposite of what we have taken. What we have taken. That is only the common sense of this negative sign. That meaning of this negative sign is only this much. If whatever the direction is given, you have taken the opposite direction. So exactly the current is in this direction, not just opposite of whatever the direction you have taken. Clear? Just note it down, please. If you are able to understand this much, please note it down. Clear? Okay. So let us, we will solve a lot of questions. Just we are covering in this class, we will try to cover the small concept. Okay. Now the next small concept is, first is series combination of resistance of series combination of resistance. Okay. See, what is series combination of resistance? First, what do you understand by series combination? Series combination means simple. That is always that definition is always true. Means the current will be same. Or you can say end. First is what is the exact meaning? That is end to end connection. end to end connection, sorry, end to end connection, end to end to sorry end to end. Wow, my English is basically end to end connection. Clear? Means there is a end to end connection is there. That is the important thing. The connection is end to end. Okay. One minute. Okay, so there is end to end connection, first thing. Second thing, if there is series connection, then the current will be always same. That is always true. Current is always same. Remember this. Okay, it is always same. So for example, if suppose there is n resistance are there, resistance R1, R2, like that, we have n number of resistance, and they are connected with a battery of voltage V. I want to replace this whole thing to an equivalent of one resistance which has a resistance R net that is connected across the same battery V. Then how will I do? So suppose here the current is I, the battery give a current I from here. Okay, and it will take the same amount of current. That is a property of battery. So the current will be same in all resistance, obviously. So what is difference? The voltage will be difference. The voltage will be different. Here the voltage will be plus minus V1, then it is plus minus V2, then it is plus minus like V3, like that it will be plus minus Vn. Correct? No doubt. Okay. So I can write, but by KVL I can say my V means this voltage V. If I go from here, or what I will do, I will take it as 0. So this value will become V. So let us write the KVL. V minus plus minus V1. Similarly, minus V2 minus V3, like that it is minus Vn is equal to this potential is 0. So from here you get V is equal to how much? V1 plus V2 plus V3 plus dot 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 Vn. Okay. Now what is V? V is what? Suppose here also the same current I, obviously, because it is a series combination, so current will not change. So I, so in this, if in this circuit I will apply the KVL, let us take it as 0. So this potential will be V. So I will apply a KVL V, and here it is again plus minus. So V minus I R net is equal to 0. So my I will be, or V is equal to how much? I into R net. Correct? Similar, so I can write my V is equal to how much? I into R net. Now what is V1? Can you tell me what is V1? See, the current I is there. What is the resistance of this? R1. So what is V1? I into R1. Correct? Similarly, I into R2, I into R3. Like that, it will go to I into Rn. So from here we have got, from here what we have got? We have got my R net is equal to how much? R1 plus R2 plus R3 dot 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 plus R, means the total resistance of a series combination is R1 plus R2 plus R3 plus Rn. Second thing, if special cases, if R1 is equal to R2 is equal to dot 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 equal to Rn is equal to R, so my R net will be equal to how much? That will be equal to n times of R. Correct? Any doubt? Okay. And one more thing, okay, so suppose if I ask you one example, suppose there is a circuit, suppose this voltage is V, and I have connected a resistance R1 here, I have connected a resistance R2 here, and the voltage drop is V1 here, and the voltage drop is V2 here, and suppose the current is I here, I is flowing, then how will you find V1 and V2? Can you tell me some quick method? See, one thing we know, what is the ratio of V1 is to V2? That will be V1 is how much? IR1, V2 is also IR2. I will cancel out, so I can say it is a ratio of R1 is to R2. And what is my V, like what is my V, total V? V is equal to V1 plus V2. So I can say my V1 will be how much? It is in the ratio of R1 is to R2 na. So I can say it is R1, V1 is ratio of R1 divided by sum of these two resistance R1 plus R2. And what is the total voltage? That is V. That is my V1 direct relation. Similarly V2, that is R2 upon R1 plus R2 into V. That is a direct relation to find the potential. If suppose there are 3 number of resistance will be there, then what will happen? Then simply this will become R1 is to R2 is to R3. Then what we will write? We will write V1 is equal to R1 upon R1 plus R2 plus R3. That how we can extend it. Clear? I hope you are clear with the series combination. Clear? Let's take one example, or we can take the example after, or let's take one simple example so that it will be better clear, more clear to you. I am saying, like for example, let us take, we have 2 ohm, we have 3 ohm, we have 5 ohm, and what is the battery voltage here? Plus volt. The current, suppose I. See, what is the basic method? Basic method, what you know from class 10th? Basic class 10th approach. By class 10th approach, how will you solve if I given you this question? What you will do? First you will calculate R net, sir. It is series combination, sir. First I will do 2 plus 3 plus 5, that is how much? 10 ohm. So sir, I will be how much? Sir, I will be 10 upon 10. Sir, it will be 1 ampere. That means 1 ampere current will flow from here. Okay, 1 ampere will current flow. So what is V1, sir? Sir, V1 is a voltage drop across R 2 ohm. So it will be 2 ohm into current. Current is 1 ampere. So sir, 2 volt. Okay. Similarly, what is V2? Similarly, sir, what is V2? Sir, V2 will be again, what is the voltage drop? That is 3 ohm. That is 3 into current, sir. So that is 3 volt. Again, what is V3? V3, sir, if you will see, sir, V3, this is also very simple. So it is how much, sir? Plus minus, V3 is how much, sir? 5 into 1, that is 5 volt. So this is the basic approach, class 10th approach. But now you have to be smart. Why? Because now this is going to be the some part of the circuit. Now this is not going to be a alone circuit. This is going to be the some part of the circuit. In that circuit, you won't apply this much method. If I have to solve this question, how I will solve? Smart way. Now you are in class 12, you are dropper. So how you have to approach? Smart way. What is a smart way you have to solve? In a smart way, you have to simply do what? Sir, I will simply take this circuit. What are you doing this thing? There is no need of this thing. You will simply say me, take this circuit. 1 minute. Let me take this, note down this circuit. No need to calculate this current, sir. You can simply solve it. No need to calculate this current also. What is, see, V1 is to V2 is to V3 is how much, sir? That is R1 to R2 to R3 ratio, correct? What is R1? 2 to 3 is to 5. So I can simply say my V1 is equal to 2 upon 2 plus 3 plus 5. 2 plus 3 plus 5 into 10. And V2 is equal to how much? 3 upon 2 plus 3 plus 5 into 10. And simply V3 is equal to 5 upon 2 plus 3 plus 5 into 10. Direct answer. Same answer you will get, 2 volt, 3 volt and 5 volt. Just in simple step. One line solution. This is a one line solution. If you do it, it is a simple one line solution. I hope you understand the way how to calculate the potential if it is a series combination given. Correct? Are you clear with this thing? Okay. Now the next small concept is, that is parallel combination. Okay, parallel combination of resistance. Why I am writing of resistance? Because parallel combination is only for the resistance, na? Because it is not always true. There can be a parallel combination of battery also, parallel combination of current source also, voltage source. This all things will come. Okay, when you go for like higher studies, when you do engineering, generally I am talking about engineering. NEET student won't get this, but if you are doing engineering, there is a separate chapter for this circuit theory. There is a separate chapter, and there separate, not chapter, separate course is there. There you learn about all the concepts about how to solve a circuit and how to, so there you will understand there is a parallel combination of resistance also, current also, voltage source also, lot of things are there. Okay, if you are thinking this is very tough, you are thinking very small, these are the very like basic things, real toughness will come later. Okay, so now let us take parallel combination. In parallel combination, what we are going to do, simple thing. So this is my resistance R1, this is resistance Rn. Okay, like this, up to Rn we have a resistance. Okay, and they are parallel connected. Parallel combination means, what is the meaning of this? First, let me understand, let me help you to understand what is the meaning of parallel combination. That is parallel combination. But what is the meaning of this parallel combination? See, parallel combination means, first thing, that is potential is same. Simply you have to remember potential is always same. Potential is same. Okay, if you see the potential across R1, that is also V, because because if this is 0, this will be V, correct? This is also V, this is 0. So you can see this will be V, this will be 0, this will be V, this will be 0, like this will be this. If you see all across all the resistance, the potential is V, like that. It is same for all the resistance. But if you see the current is I1 here, I2 here, like that. The current is I3 here. The current will be different. So if suppose the current I is flowing from here, I will come here. So what is the current now? The current will be here. In this case, it is I1 plus I2 plus I3 plus dot 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 plus IN. And if we want to write the current in each branch, how will I write? I will write it as V upon sir R1, V upon sir R2. Similarly, V upon some R3, sir, like that. Some V upon some Rn. Now what is I, sir? What is I? I is basically what? If it is equivalent, will be something like this, R net into some current I will be there, same as the previous one, some V voltage. So what is my I? I will be V upon R net. Just put this value here, V upon R net. So from here, what is the resistance you will get? You will get the resistance 1 upon R net is equal to how much? 1 upon R1 plus 1 upon R2 plus 1 upon R3 plus dot 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 1 upon Rn. Now if you see, if my R1 become equal to R2, become equal to R3, like that, become equal to Rn, and that is become equal to R. So my R net will be how much? R by n, sorry, it will be R by n, correct? And one more thing, that suppose if there are two resistors are connected in parallel, this is suppose R1, this is suppose R2, and then you have to calculate R net. Then simply remember there R net is very, because it is going to be used lot of time, R1 into R2 upon R1 plus R2. Okay, just directly remember this because it is going to be used lot of time. Now here we have to talk about the current division, because here the potential is same. There we have talked about voltage division, how to do the voltage division. Here we are going to talk about how to do the current division. Let us discuss. Let us discuss about the current division. Okay. So let us discuss. Suppose I have connected a two resistance. Just take an example for two. Suppose this is R1, this is R2, and this is connected to a voltage of battery V. Correct. And suppose I want to find the current I1 and this current is I2 at this R2. Okay. This will be R1, this is R2. How to solve this? Basically, first what you have to do, first you have to calculate the R net. R net. R net will be obviously R1 by R2 upon R1 plus R2. That is clear. You just calculate this. Now what is I1 is to I2 ratio? It will be simply 1 upon R1 is to 1 upon R2 ratio, correct or not? Because V will be the same. You can cancel out V. It will be how much? 1 upon R2, R1 is to R2 ratio. So I can write it as R2 is to R1 ratio. Just like cross multiply. You will get R2 is to R1 ratio, correct? Now, so from here, if someone asks you what is my I1, I will write R2 upon R1 plus R2, that is I. I means the current which is flown from this battery. Similarly, I2 is how much? I2 is R1 upon R1 plus R2 into I. So this is how you distribute the current in the parallel combination. Here you have to calculate the total current and simply you have to apply it. See, remember that in voltage division, when you are doing the voltage, then their resistance are coming for the same, like resistance are coming in the same manner. What do you mean by same manner? See, we are calculating the resistance across voltage across V1, so resistance R1 is above here, V1 R1. But here, if you go for current, you will see that here this is I1 R2. That is a difference. Okay. Let's take one example, then you will understand it better. Example, class 10th approach. What is class 10th approach? Suppose this is 2 ohm, or this is 4 ohm, or we can do one more thing. 6 ohm and 3 ohm. Suppose they are connected together, the 2 volt of battery. My aim is to calculate I1, I2. How to calculate? First is R net. Sir, R net I am calculating, so it will become 2 into, sorry, not 2 into, na? It's 3 into 6, sir, plus 3 plus 6. So that will be 2 ohm, correct? So my I will be how much? 2 by 2, that is 1 ampere. Now 1 ampere current is coming from here. So what is the drop across the, see, this circuit can be drawn into this form. Basically, we have a 2 volt of battery and this is converted to 2 ohm resistance and current is 1 ampere. So what is the drop across this battery? That is 2 volt. So that drop across this will be also 2 volt and the drop across this will be also 2 volt because they are connected in parallel. Na? So if the drop across here is 2 volt, the drop across here also 2 volt, 2 volt. So what is my I1? What is my I1? So I1 will be very simply, you can write I1 is 6 upon, what is I1? That is I1 will be 2 divided by, 2 divided by 6, that is 1 by 3 ampere. And what is I2? I2 is how much is the voltage? 2 divided by 3, that is 2 by 3 ampere, correct? And if you add this, you will get 1 ampere. See, if you add this, you will get 1 ampere. But what is a smart method? Smart approach. Let us see the smart approach. That is for comparative exam. If this is my circuit and they have asked me to calculate what is I1 and I2, I am not going to do these all steps. I will solve it in a single line. How? Let us see and understand. Do you think I will going to do this much of steps? Then that number of steps are not required. I can directly do it in a single line. How? Let us see. Just let me draw the circuit. This is 3 ohm, this is 6 ohm. I will take this potential equal to 0, so this will become 2 volt, this is 2 volt, this is 0, this is 0, this is 2, this is 2, this is 0. So do you know the potential across this? Directly write na 2 by 3, directly write 1 by 3 ampere. Why you have to do this number of steps? Directly you can do that, and you can apply that current division also, they will get the same value. But in parallel combination, generally there is no need to apply. You can directly use this concept. Simple. I hope you understand how to divide the current in this way. Okay, means suppose suppose this is given. In this example it is not clear. Let us take one example, then it will be clear what I am trying to say. Let us consider this case. Suppose there is a 10 ampere of current is coming, okay, and you have a resistance like this, that is 2 ohm, this resistance is 3 ohm, and this resistance is 1 ohm. Now here you have to divide the current in this case, because now here you can't write the potential across the battery. Here you can't write, because you don't know the potential of this point, so you can't assume. Now here you have to apply this current division from way which I have told you. One thing is clear, that they are connected in parallel, so the potential will be same. So how to divide the current basically? So how to divide the current? The current division will be, suppose the current is I1, I2, I3 in this. So I1 is to, I2 is to, I3. The current here is I1, I2, because I don't know the potential na, so I cannot assume some value, because I don't know the potential about this. I only know that 10 ampere current is coming. So here there is no need to apply this thing, but here you have to apply. There is no other way. So what I will do basically, I will simply take it as I1 is to I2 is to I3. That is 1 upon R1 is to 1 upon R2 is to 1 upon R3. Correct? And then I will write my I1. What is my I1? If you want, you can put the value here, 1 by 2, 1 by 3, and 1 by 1. See how to simplify this thing. Just take the LCM of the denominators and multiply that quantity in the numerator. So if you take the LCM, it will be 6, so it will become 3. If you multiply in the numerator, it is 3 is to 2 is to 6. So now you can write I1. I1 is 3 plus 2 plus 6 into 10 ampere. That is I1. I2 is how much? That will be 2 upon 3 plus 2 plus 6 into 10. Similarly I3, that is 6 upon 3 plus 2 plus 6 into 10. That is my I1, I2, I3. Simple way. But if you try to apply according to class 10th way, what you will do, you will first find the parallel combination of this. Then you will get R equivalent. Then you multiply that 10 with R equivalent. You will get the potential. So that is a potential across this. Then you will apply the I value. But there is no need. Just you know this current, you know the R1, R2, R3 value. Just you find this ratio, and simply you can write the current I1, I2, I3 by using this. If this is the case, then there is no need to apply that also. I am telling for this type of question. Okay. So I hope it is clear to you when we have to apply this current division rule and when we have to apply this. When we have to apply this voltage division rule. So this is the some basic small concepts we have covered in this session. In the next session, we are going to solve the example on this, all the concepts which we have covered. Please revise each and everything, then attend the next session, then we will understand the things in better. And if you have liked this session, please like it, share it and subscribe it. Have a nice day. Thank you.